We'll be giving you out some USB keys. You're encouraged to repeatedly shove them into your laptops and ignore any warning messages that you see. Obviously, you don't have to use ours if you don't want to, but the next module is talks about live booting from USB keys, and we'll be DDing the Kali image that we just built to them. So if you prefer using your own USB key, that's fine. If you need one from us, we'll be walking around and giving them out to you. We'll be going through all of you, don't worry, we have enough for everyone. We've got all of these guys covered. Back row, yeah. That's okay. I don't mind shouting, I'm good with that. I do it so often. You're fired! Sure. More USB keys. See? Can I have Mike? Anyone missing USB keys? Good. 8 gig USB 3. Thank you, Mike.
Welcome again. Hello. Can I get the podium mic, please? Got it, thanks. Welcome again to day 2 of Black Hat 2015. Please stop by the business hall located in Shoreline A for sponsored sessions in Theater A and B. Be sure to check out all the Black Hat Arsenal in breakers D, E, J, K. Sponsored workshops are in Mandalay J, K, L. And please put your cell phones on vibrate or silent. We're currently in South Seas IJ. This is the Kali Linux Dojo workshop number 2, Kali USB setups with persistent stores and LUKS nuke support. And I'll turn it back over to Mutz.
Thank you very much. Great. So thank you once again for joining us in our second workshop today. Both of these workshops have been designed as live interactive sessions, so it's a workshop as opposed to a talk. So mostly aimed at these guys here sitting up front, connected with their laptops, doing evil foo. And I think, do we have any new people? Can I see a quick show of hands? Okay, so hello, my name is Matthew Haroni. I'm the founder of Kali Linux Project. And we can skip the duplicate introductions. So, we've been talking about how Kali Linux is a wonderful pen testing platform, a wonderful pen testing environment. And we've also been talking how I've been involved in evangelism, trying to convince the world that Kali Linux is more than just a collection of tools. And by that, what I mean is that there are all sorts of very, very interesting features in Kali Linux, again, designed for professional use of penetration testers, forensics workers, reverse engineers, malware analyzers, etc. So we've seen one cool feature today, which was live build and the ability to modify a Kali Linux ISO or build a Kali Linux ISO with all sorts of funky customizations, from trivial things like, overwriting wallpaper or whatnot, to less trivial things like running chroot hooks, which allow us to change configurations at build time so that the resultant ISO will have extra features or additional configurations which might not be there by default. This also includes adding additional tool sets, adding custom packages, adding scripts. One of the things that I've seen happen a lot is people download a deb file. A classic example of this, I guess, would be Nessus, like a Nessus deb file. They plop it in the includes chroot directory, and then at build time, that deb file gets included in the build, and then your custom Kali ISO will always have whatever tool, Nessus or whatever, pre-installed. So that's pretty cool. So once again, if you have a ready-made ISO from the previous workshop, that's great. If you don't, then feel free to download a pre-made ISO. It's a light variant build, so it's XFCE, has a very limited tool set, but of course any additional tools can be manually installed. Attention, open your eyes and be very, very careful in this next stage, because the next step that we'll be doing today is we'll be DDing these Kali ISOs to the USB keys that you have just received. Now, please be careful. Most likely, the device that you want to be DDing to is not /dev/SDA. You do not want to end up like this young gentleman here, unhappy about blanking out your laptops. If you're unsure, or if you'd like some advice before DDing your ISO, and the instructions for that are here, then raise your hand and we will help out and make sure that you're not about to format your hard disk. We will not resume any responsibility, etc., etc. Okay, just make sure you don't mess up. So once you have that ISO, DD it to /dev, whatever it comes out, whatever your USB device comes out as. And the command sequence for this workshop can be found in a file called workshop2.txt. The DD process should happen fairly quickly because we are using USB 3, so it shouldn't take more than a few minutes. Also, the ISO that we built is a minimal ISO, so instead of being 3 gig, 3.3 gigs, it's less than 1. So it should happen fairly quickly. Let me take one of my own USB keys here, plop it into one of the repositories. Can you do that for me, please, Jim? And start my own DD process. So the image that I built just now is right here. Oh, you can't see that. So the image that I built right now is here. This is the image that I built in the first workshop. A quick dmessage command will show me that the USB key is indeed SDB2. So all I do now is DD images. Can someone sanity check me to see that I'm not doing something horrible to the repo? Of /dev SDB. So this is the DD command. Again, this command was on the slide. I'll put that slide up in a sec. And I'll let it rip. So this is the slide with the command. If you have doubts about what you're DDing where, just raise your hand. Better safe than sorry. And we speak from experience. Jim, can you? since you're in VM, you're in a slightly better situation. Let's see, yes, because the worst that can happen is you kill your VM. Iggy? You're welcome. She needs to connect her USB key and have it DD'd. How's the DD process going? Everyone safe and sound? It's happening. Can you give me a satisfied nod if it is? Yes? Okay. Sorry, camera guy, I know I'm going back and forth. I apologize. Sorry, you need the previous slide? There you go. DD is progressing. Is DD finished for anyone? Show of hands? Yep, okay, so we're just getting there now. Good. So we're in good time. So just as this is happening, this is an opportunity for you to yap a bit and tell you what we're going to be doing. Once we've DD'd the Kali ISO onto the USB key, what we can now do is take that USB key and live boot from any device, any computers that we like. What this will mean is that every time that we boot from this read-only environment, we'll essentially be getting a new blank, clean slate of Kali. And of course, as live boot boots into RAM, no changes that we will make will actually be saved to the USB key. And this is an important key to understand here, because the USB drive or the ISO on the USB drive is read-only. So every time you boot, Kali will boot into RAM. And that's also something interesting to think about, because if you have a 7 gig ISO, that means you need to have at least 7 gigs of RAM to hold that ISO. Okay? If you have a minimal ISO like we do here, you don't need that much RAM. And again, this is one of the reasons why you might want to customize your ISOs in the first place. So every time we boot this ISO, it boots into it's not exactly read-only, but shall we say non-persistent environment. So any changes that we make won't be saved. Now, one of the things that we like to do is often travel with blank laptops and Kali on a USB stick. And then if we end up in an engagement somewhere, we boot from a USB stick, especially with today's USB 3 drives. Speed is no longer much of an issue, and we can do our work from a USB environment. But now comes the question of what happens if you want to start saving files. Say you're in the middle of your engagement, and now you're writing a report. And of course, you don't want this report to disappear the next time you reboot. You would actually like to be able to save stuff on the USB device. And this is where persistence comes in. And this is, again, another cool feature in Kali, which allows us to define additional partitions on our USB drive. And those partitions can be used as a persistent storage to the non-persistent ISO. Okay, so think of it this way. We define an additional partition on the USB drive. Any changes that we make across a reboot of the live environment is saved in that partition. And then the next time we boot, we can optionally choose whether we want that persistence partition to be included in our boot environment or not, which is cool. Again, because you can just plug in your Kali USB, decide whether you want to boot into a nice clean environment or into an environment that contains your changes from earlier. So that's all good and dandy, but what happens if the information that you want to save is sensitive? Again, think report of a client engagement. You don't want this thing to be unencrypted, because if you were to lose this USB key, it would mean horrible, horrible things. So one of the things that you can do is not only define persistence, not only define a persistent USB partition, you can define an encrypted USB partition. And what that will entail is booting up your USB drive, having the option at boot time of booting persistence with encryption or persistence without encryption. We'll see that in a second. And then if you boot persistence with encryption, you're actually prompted for an encryption or decryption password. And this is, again, based on LUKS. Okay? So that's pretty cool, because now that means that we can travel with sensitive data securely. Now, earlier I was talking about the LUKS nuke feature, which allows us to nuke our encrypted drive in case we need to. We'll talk a bit about this later, because it has some interesting aspects here about, wait, if now law enforcement stops me and asks me to decrypt my laptop, if I suddenly nuke it, that's not good. That's obstruction of justice. So that's not what we're after here, right? But there are many, many scenarios where this can be useful, and we'll describe them later on today. So again, USB live boot is one thing. Then we have USB live boot with persistence, and then we have USB live boot with encrypted persistence. And the fact is that we can actually have multiple persistence stores on our USB drives. So you don't have to choose whether your partition will be encrypted or not. You can actually have multiple stores, and then at boot time define which partition you want to load, if at all. Does that make sense? Great. How's the DD going? Can I see a show of hands? Okay, a bit more. How many people are in progress? Show of hands? Great. Okay, so I guess a couple of minutes more are needed. Okay, so this is a quick slide showing the various options of live boot that is supported in Kali. So regular live boot, persistence, encrypted persistence, and there's another boot mode which I described earlier in the first workshop, which is the forensics mode. And this is a mode that will actually boot into a forensically sound environment. So if you're doing forensics, that's the one for you. And this is a small graphic simply describing the ability to have multiple persistent stores, okay? So this is the Kali ISO DD'd on our USB drive, and then we can define additional partitions, again, persistence or not. Sorry, encrypted or not. This is a default Kali 2.0 boot screen. In fact, this is also what Kali 1.0 looks like, just without the changed graphics. What you will see here is that there are two boot options. One is called live USB persistence, and one is called live USB encrypted persistence. And these boot options are there by default. And the way these work is that if you actually go ahead and define a partition, then these things will kick in and use that partition as a persistent store. The secret behind these boot options are the boot parameters themselves. I'm not sure if that's visible or not, but these boot options actually describe a persistence label, which by default boots up a partition which is labeled persistence. Okay, so just an FYI on how this works. So now, workshop02.txt is going to entail the following process, okay? And I'll describe it by words to begin with, and then we'll move on to the actual commands needed to do this. And again, I assume that the DD process is still ongoing, so I can yap away. Once the ISO is DD'd, we will plug it into our computer. We will create two additional partitions. In fact, we can create as many as we like, but for this dojo, for this workshop, we'll create two additional partitions. We'll format the first one with extended file system 3, and this will be our non-encrypted persistence partition. We'll label it persistence. and then create a persistence.conf file on this partition, which defines what exactly I want to persist, or which directories I would like to persist in the Kali USB. Usually it's just a /, which means persist any changes over the whole file system. But this can be optional. You can decide to persist only a specific directory. So once that's done, we've essentially defined our first non-encrypted persistence partition. Then the next step will to be used crypt setup to format the second persistence partition, and this will be our encrypted partition. And then once again, once all that is set up and we have a password to decrypt this partition at boot, once again we'll create a persistence.conf file that defines what we would like to have persist in this partition. And this is essentially a walkthrough across the various acts that we'll have to various commands that we'll have to give to make this happen. Finally, if you want to invoke the nuke option, the LUKS nuke option, we can optionally set up a LUKS nuke password. Again, meaning that given the wrong password, given a specific password, rather than decrypt the encrypted partition, we can actually destroy it. So let's see what this requires. I'll quickly open up my workshop2.txt file. Again, you can find these on the repositories. So archive.kali.org/workshop02 with no spaces, with no underscores or anything, .txt. And essentially a copy-paste, a careful copy-paste should work out of the box. So looking at my ISO, which is just being DD'd on my USB drive, if I were to now fdisk -l/dev sdb, what you'll see is that DDing the ISO on a USB drive will actually result in two partitions on the USB drive. One partition is the Kali goodness, and the second partition, or did I get this the wrong way around? No. The second partition is actually an EFI boot partition. Okay, and this is natural, this is the way it's supposed to be. So now if we want to create two more persistent stores, we need to define two more partitions. And what better way to do that than with parted? So I'll use parted to list and then create two additional partitions. In this case, the ISO that I built is 909 megabytes in size. So I'll simply define another partition starting from 909 to 5 GB, and then from 5 GB till the end of the space available on the USB drive. Okay, so now what I should have is 4 partitions set up. This guy is going to be my persistent non-encrypted partition, and this guy is going to be my persistent encrypted partition. Wow, these are real mouthfuls, huh? Great, so once these are defined, I'll quit parted and continue our foo. So again, looking at this from a different angle, fdisking my USB drive now, 4 partitions in total. Next step, create the non-encrypted partition. So we'll format it with extended file system 3. And very, very importantly, we will label this partition with the label persistence. Again, workshop02.txt contains all of these commands, so you don't have to squint and look at the screen here. This is a really important step, by the way, because if we don't label this partition correctly, it won't be used for persistence. And this is where most people get things wrong. Okay, so it's really, really important to label these partitions. Can I get a call on time? How much time I have? 20 minutes or so? So now that we've created a file system, created the partition and formatted it with the right file system, the next step is to throw a persistence.conf file on that partition, and we do this by simply mounting it to /mnt_usb, and then creating a persistence.conf file, which contains this text, which means please persist any changes from the root directory downwards. Okay, and then once that's done, we unmount the non-encrypted partition. So that was simple enough. Now, we want to deal with the second partition, which is the encrypted partition, right? So we'll use crypt setup to format the bad boy. Okay, just make sure that you've got your device names correct. So if SDB3 was the non-encrypted partition, then SDB4 will be the encrypted partition. It asks us for verification, we say yes, and then it asks us for a decryption password, which naturally, me being security conscious, will be Tor. And I'll verify that password, and now we have a partition which is LUKS encrypted with a Tor decrypt password. Next step is to mount this partition as well. Password is Tor, and I will once again create a file system, an ext3 file system on this encrypted partition. And then I will label it, once again, persistence. And this is an important step. Once it's labeled, again, we need to complete the persistence feature, and that is done by simply mounting the encrypted partition, adding a persistence.conf file, which once again defines what we want to have persist, and finally unmount the encrypted partition. So that's it. We now have the setup that is required to have a live USB key with two partitions on it, two persistence partitions, one encrypted, one non-encrypted, and these partitions will retain any changes that we make during our live sessions. So now if you're there at your client's location and you're writing your report, and then you reboot your live USB key, that change will remain on the partition itself. Great. Lastly, if you remember the LUKS nuke feature that I was talking about earlier, that feature that on one hand, you can define a password to decrypt your partition at boot time, but then if you enter another password, it will destroy the partition. So the way you actually invoke that is by defining a LUKS nuke password. Let me show you the syntax for that. Again, the syntax for this is, this whole feature is much well described in our blog posts. So if you Google Kali Linux LUKS nuke, you'll find the whole history behind this. But this is how we now add a nuke password. So if my decryption password was Tor, my nuke password will now be Mati. I need someone to remind me of this because obviously I'll forget. So M-A-T-I. Oh, right. The first password that I need to give is the real password, so that will be Tor. And then the new password for nuking will be M-A-T-I, and then M-A-T-I once again. Okay, so Tor will decrypt the encrypted persistent storage, and Matty as a password will destroy it. And that is it. That is all we need to do to get this stuff working. So essentially, once you've completed this process, you should have a USB key with 4 partitions all in all. And if you take this USB key and you plop it into a computer and try booting it up, this is what's going to happen. And allow me to demonstrate this in VMware. So I'll plop this here. I'll turn on VMware. And I'll go to live boot. So I'm connecting my USB key. Thank you. I'm connecting my USB key to a computer. Again, this is in VMware, so it's a bit funky because you have to emulate USB booting. Please ignore this screen. I'll make sure that my USB key is passed onto the VMware machine, which it is, and I'll press boot. So this is our modified ISO booting. You can see that it's the modified ISO because we have the unattended installation option here from the first workshop. So let's go to the first option of live USB persistence. Okay, so I'll hit enter. The USB boots Kali, again into RAM. Hopefully I had a sense of giving enough RAM to this VM. SquashFS file is being loaded. And Kali 2 is booting up. It's booting up into XFCE, right? Because we created a minimal or a light version of Kali with a custom wallpaper. Remember that? So again, this is the same ISO that we built in the first workshop. So hopefully we'll see an XFCE environment with a beautiful Black Hat wallpaper. So again, this is a live boot environment. So I can now open a shell. And let's quickly ls the user directory. I'll create a file called persistence.txt. It will have some information on it. The file is created on the file system, and I will now reboot. I reboot. Once again, boot from the USB. Choose live USB persistence. Notice that this guy already has the persistence boot parameter defined, and by default, as I mentioned earlier, a partition with the label persistence will be booted automatically. So now when I hit enter, once again, Kali will boot, and very hopefully what we will see is that the change that I made earlier will now be overlaid on a clean Kali ISO boot, and the change that I made should hopefully persist. However, it will persist in an unencrypted partition. Okay, so demo gods be with me, ls-l, and persistence.txt is there. Now, this is different from a normal installation, right? Because now if I reboot and I choose a regular live boot, then I'll have a blank version of Kali with absolutely no additional files on it. It's going to be a live boot. You'll have to take my word for that. Let's look at the second option. This is probably what's more interesting to people who have to travel with sensitive documents. Hitting enter on live boot persistence with encrypted options should boot up, and at some stage should pause and say, hey, if you want to use this partition as an encrypted storage space, please tell me what password was defined because this is encrypted and I have to have a password to decrypt it. So fortunately, my password was easy to remember. It was Tor. I type in Tor and the persistence encrypted partition is loaded up into my live session. So now, if I do the same exercise here, I've got a blank environment, I'll echo my secret into a file called persistence. Excuse my typos, doesn't really matter. Okay, so there you have a file present on the encrypted storage. And now if I reboot and reload that encrypted persistence partition, I should see that file again. And if someone tries to boot this USB drive and they don't know the uber secret Tor password, they won't be able to overlay that partition and that file is now secure. So once again, it will ask me for a password. I will type in Tor, and the encrypted partition is now decrypted and overlaid on top of my live Kali installation. And once again, hopefully, if I look at my home drive, I should see this guy. So that's great. That worked. Now what happens if I nuke my USB drive? Okay, remember, LUKS nuke, right? So something has happened, emergency situation. We'll talk about this in a second. What constitutes as a legal emergency situation? It is an interesting topic here because when we introduced this feature in Kali, there was a lot of noise around this. We'll see that in a second. So right now, a situation arises. I tried booting the encrypted persistence partition, and rather than giving the password Tor, which is the correct password, I'll give in the password Mati, which is the nuke option, so M-A-T-I, enter, error, decrypting. Okay, I'll try another password, Tor, the original password. Please unlock, Tor. Error, no. So that didn't work. I've essentially nuked my encrypted partition now, and in fact, Kali has loaded into a clean ISO, into a clean live boot environment, not including, oh crap, not supposedly including the encrypted partition. I must have typoed something there at the beginning. I can try that again. Please go ahead and try this yourself. Okay, if you want to try to invoke the nuke option, go ahead. Just remember to test that at the end, because once you do that, you're essentially deleting your key slots of the encrypted partition. Okay, so do that at the end, the whole LUKS nuke thing, and I'll see if I can rectify this demo just so that we have proof that this thing actually works, and it does, so we might as well. Go ahead, follow workshop o2.txt. If you have questions, we'll be roaming around. Any questions so far? No? So you're good? You've managed to get workshop o2.txt, you have the command? Yeah? Okay. So let's see what's going on here with this nuke stuff. Unlock disk, password was MATI. All right, so once again, I invoke the LUKS nuke password. Hopefully, I didn't fat finger my password, so we should see that it doesn't boot the encrypted partition. So now, ls-l, and there you go. Okay, so that actually worked. I must have fat fingered something in the process. So we've actually destroyed the encrypted partition. Well, not really destroyed it. I'll talk about that in a second. But I'll let you guys complete this exercise for now. And then in the last 5 minutes, I'll open up a quick discussion about this LUKS nuke feature and how to use it in a practical environment. Pardon? It did. The partition doesn't get deleted. In fact, what happens, I might as well put that up. What actually happens is that the way LUKS works is that you have some key slots defining your passwords. And what the LUKS nuke option does is it just deletes these key slots away from the partition. So it doesn't destroy the partition, it just renders the data on the partition useless. Okay? While you guys are typing this in, I have a few minutes just to describe this LUKS nuke use case. And essentially what I'd like to do is summarize the comments that we received when we introduced this feature into Kali. So imagine once again, you're traveling with your laptop, with your Kali device, whatever it is, USB, and you're stopped by law enforcement and you're asked to decrypt your password, right? So you boot up, you have the option to type Tor, or you have the option to type Mati. Mati being destroying the data on the drive or rendering the drive useless, and Tor being decrypting it. If you were to, I'm not a lawyer, this is important to mention, and this doesn't constitute legal advice, etc., etc. But if you were to actually destroy the drive, that could be obstruction of justice, and that will land you in a very nasty place. So this is not the scenario that we are aiming for. However, imagine a situation, once again, that you're pen testing a client. You now have a report, a very sensitive report on your USB drive, and you now need to travel with this, and you're afraid that this might be intercepted on the way. So one thing that you can do is take your USB drive or take your computer, make a quick backup of the key slots, of the LUKS key slots, email that backup to you, or send it via some third party to a location where you feel safe. Use the LUKS nuke option to simply delete the existing key slots, and then travel with a corrupted USB drive, Okay, and then if you're intercepted on the way and someone wants you to boot your encrypted partition, you simply cannot. And this is the way the EFF recommend that you do this. And then once you get to your endpoint, to your safe location, after your travels have completed, you can download your key slot backup, reapply them on your USB drive, and then once again, access your encrypted partition. And that is the scenario that we had in mind when we built this feature into Kali, which essentially allows us to travel with sensitive documents without the fear of having them intercepted on the way. Does that make sense? Okay, so no to obstruction of justice, yes to traveling safely with encrypted data. If you guys have questions, feel free to ask. Okay, we're roaming around you. Absolutely. All of this is documented. There are some very slight changes between Kali 1 and Kali 2, which will be updated during the release day and I guess a couple of days after that. So both everything that had to do with the LUKS nuke stuff and as well as the live build stuff, which has very slight syntax changes. No nuke for NetHunter as of now, because you're reliant on the actual Android's encryption stuff, which we haven't messed with. Questions, general questions, not related directly to the practical stuff? Okay. If you need help, yell. How many of you were aware of these features before you came to this dojo, by the way? Can I see a quick show of hands? Some of them, few. So this is great because this is exactly why we're having these dojos, trying to spread the word about what Kali can do other than run Nmap, you know? And these are the type of features which we're talking about when we say it's a pen testing platform and it contains more than just a collection of tools. Maximum, no limitation. You're talking about a partition that will load as a persistence partition. It has to be extended file system 3 or 4. Okay, and then you don't really have a limitation. You can definitely have a 32 gig partition and that will work fine.
Like for a forensic tool, you might want a large partition to download an image of the drive to. So
correct.
I have a 128 gigabyte.
Absolutely. So for example, if you're working, if you've got a large file, a dump file, 50 gig file that you want to keep, you can definitely, if your USB size supports it, you can definitely configure a 64 gig partition. It will work. You don't have any restrictions on these sizes. Again, which makes this a really, really useful feature.
Yeah, it does.
I'll quickly add my email and Twitter handle to this slide. So if you have any questions which you'd like answered outside of this dojo, you're welcome to send us questions. And we will announce the availability of the slides as well as the workshop text files, so that you guys will be able to download this externally. So this is Kali Linux. Is that large enough? No. Great. Ladies and gentlemen, we've come to the end, to the conclusion of our second workshop today. I would like to thank you all for attending and coming here. Thank you very much.